Hello, welcome to the simple linear regression analysis, and today I would like to exactly derive a formula for a linear regression function for you using two approaches. Way number one, the calculus approach involving partial derivatives, and way number two, if you do not like derivatives, I will use a pre-calculus approach. As you remember, we discussed it in the class. We're using the least squares method to find that unique line where the sum of the squares of all the differences between the real outputs, the observed outputs, and the outputs offered by my model, the sum attains its minimum. In other words, this is how I visualize it. If you have your scatter plot, the data points here, you look at the differences between the data points and the outputs on the model line, you build up the squares with the sides on the sides of those differences, and the sum of all the areas of the squares for this line of the best fit will attain its minimum. So in other words, I'm looking for the line in the following form, the slope-intercept form. Beta 0, beta 1 are unknown parameters. I'm looking for those slope in intercept. Actually, y and x are not variables here in this case. They're observed values. They are given to us, xi and yi, or y hat values. So we're looking for beta 0, beta 1. They are variable parameters in this case. They're variables. The line is given in general here such that the sum of the squares of the difference yi, the observed value, minus y hat squared I1 to n attains its minimum. Yeah, this sum attains, in other words, the sum I runs from 1 to n yi squared minus 2 yi y hat plus y hat squared. It's minimum value. Now let me plug in the model for the yi, and it will be equal to the sum yi squared I1 to n minus 2 y hat. I'll distribute it here. So beta 0 minus 2 I beta 1 xi and plus y hat squared, this whole thing squared. So it will be beta 0 squared plus 2 beta 0 beta 1 xi plus beta 1 squared xi squared. Yes, this whole thing, the sum of that expression attains its minimum. This is what I'm looking for. And again, y's, x's, xi's, y's, i's are all given values. They're not variables. They're given observations. What's unknown? Beta 0 is unknown. Beta 1 is unknown. Those are my variables in this case. The slope and intercept are my variables in this case. I'm looking for that. As you can carefully see here, it's a function of two variables. It's a function q of beta 0 and beta 1. Yeah? It depends on the choice of those two variables. Now I need to minimize it. I need to find such beta 0, beta 1 that the value of that function attains its minimum. And the calculus technique is to find the derivative, make it equal to 0. And this is what skipped in many presentations. They find the derivative, they make it equal to 0, and they say this will be our minimum. Actually, it needs to be shown. That's important, necessary, but not enough for the minimum. We also know the maximum also has 0 derivative. So we need to exactly show that this is the minimum indeed. So first step would be to find the first derivative, this function dq d beta 0, the derivative of this function with respect to beta 0. First derivative, yeah? it will be equal, there's no beta 0 here, there's beta 0 here, minus 2 out of the sum, so will be summation, minus 2 out, the summation, I1 to n, yi, yeah, yi, there is no beta 0, drops out, the derivative of this one, 2 beta 0, minus 2 out, so the minus beta 0. Everything is under summation. Yeah. There is beta 0 here, so the derivative of this one will be 2 beta 1 xi minus 2 out, so will be beta 1 xi. Yeah, and make it equal to 0. So this is what they say, this is what we need for our minimum. Not exactly everything. We really need to show that this is a minimum. How do you do that? You remember from calculus, it's a second derivative. Let's look at the second derivative with respect to the same variable. D 2q d beta 0 twice. And the second derivative with respect to beta 0 will be minus 1 here under the summation. So will be added to itself n times, so it will be minus n by minus 2. It's just plus 2n. Obviously, it's positive value, obviously, yeah. No negative. N is the number of observations, yeah. The observations. N is positive. It's the number of the points we observe, never negative, in the real world. So it's the second derivative is positive, it means that this is really min point, minimum point. So this small part is always skipped, but it's important to mention. First derivative for the beta 0. Next, I have a second variable, first derivative with respect to beta 1. I also need to minimize it with respect to my slope beta 1. And it's equal to the derivative of this function, the function q, with respect to beta 1. There's no beta 1 here, no beta 1 here, here. It's minus 2 out. Out of the sum, I run from 1 to m, minus 2 out. yi under the sum, I have my y I xi, yeah, minus 2 out with respect to beta 1, so will be yi xi, yeah. I will pull it out because there will be xi's there too. No beta 1 here, no beta 1. The derivative of this term with respect to beta 1 is 2 beta 0 xi minus 2 out, so it's minus beta 0 xi out, xi out again here, yep. And the last term is this one. The derivative of this term with respect to beta 1 is 2 beta 1 xi squared minus 2 out, so minus beta 1 xi squared. So xi is here, second xi is out. Yeah? Xi is out. It's also equal to 0. So this was my equation 1, my equation 2. And the same way, the second derivative, the beta 1 twice, is equal to the derivative of this one with respect to beta 1 is xi squared under the sum minus beta 1, so minus here. So will be minus out, will be plus 2 under the summation will be 2 sum xi squared. And obviously it's also positive value. The summation of squares is positive. It's also min point. So we are on the right track. the function has a minimum for beta 0 and beta 1. We have two equations. It's actually the system of two equations. They are related. They describe the same problem. So we will find an intersection of those two solutions by using a simple substitution method in this case. Just solving this the first equation, I'll keep my summation of yi's, summation of yi's, I runs from 1 to m, and all those negative under the summation, I will move to the right with the plus sign. So will be equal to the summation of beta 0, I runs from 1 to m, plus the summation of beta 1 x I runs from 1 to m. So we have the summation of yi's. Summation beta 0 does not depend on I, gets added to itself n times, so it will be n beta 0, n beta 0, plus beta 1, pull it outside of the sum, does not depend on the I index, this is beta 1, and this is I. So beta 1 is summation of xi's. Dividing by n is non-zero value, so I will have sum of yi's over n is equal to beta 0 plus beta 1, sum of xi's over n. Yeah? What is that? Those are simple averages of the given inputs and outputs. So y bar versus x bar. So in other words, y bar is equal to beta 0 plus beta 1 x bar. Yeah, those values are easy to calculate. They are given to us. So what we have here, that beta 0 will be equal to y bar minus beta 1 x bar. So I have a formula for my intercept, beta 0. I need to find beta 1. Beta 1 is unknown. And I will find it from my second equation from here. And find the common intersection, common part, those two. From the second equation, solving this part, it will be the summation of xiyi, right here, the summation of xiyi, sum of xiyi, and those minuses under the summation will move to the right with the plus sign. Minus 2, they drop out, you know that. So will be the summation of beta 0 by xi. Beta 0 outside of the sum. So plus beta 0 sum of xi's, I 1 to m, I runs 1 to m, plus beta 1, the summation of xi squared, 1 to m. Yeah? This is from my second equation. And that's for my first equation by using substitution. If I substitute the value of beta 0 into my second equation, I will eliminate beta 0. Everything will be in beta 1, and hopefully I'll be able to carefully find my slope. So from here, it's equal to the summation xi yi, I runs from 1 to m, is equal to y bar minus beta 1 x bar. That's this one. And everything is multiplied by the summation of xi's plus beta 1, the summation of xi squared. Now let me collect those terms with beta 1. This is what I need. I need to filter it out to separate my beta 1. And hopefully this will be the formula. So it's summation xi yi I1 to n is equal to y bar summation xi's, y bar summation xi's, here minus beta 1 x bar summation xi's, minus beta 1 by this, and another common factor, so minus beta 1 from here will be minus summation of xi's squared. This is how I use my beta 1 outside, yep? I just factored out minus beta 1 from those two terms. This is what I have, and hopefully I'll be able to separate. So from here, beta 1 x bar summation xi's minus summation xi squared is equal to y bar summation xi minus summation xi yi. Simple algebra here, just do it carefully. And from here, my beta 1 is equal to just this divided by that. Yeah. So I can flip the difference here with the minus sign and flip it with the minus sign. So this is what I have here, the summation of xi yi minus y bar summation of xi's, and divided by the summation of xi squared minus x bar summation xi's. That's it practically. That's the formula. We can kind of modify it using x bar and y bar here. As you remember, the formula, that's the sum of xi's over n is x bar. The sum of yi's over n is equal to y bar. Yeah. So from here, the sum of xi is x bar by n. So this is x bar by n. So you can write it beta 1 is equal to the fraction summation of xi yi nx bar by y bar, yeah, minus nx bar by y bar. This is my numerator, and my denominator will be the summation of xi squared minus, and again, the summation of xi's is n by x bar by another x bar. So the n by x bar squared. And this is it. That's actually the formula for the slope of the line of the best fit in this case. You can see everything is given here. Xi, yi, all given pairs, inputs and outputs, corresponding inputs and outputs. So the sum of the corresponding products, inputs and outputs pairs, minus n is number of observations. X bar easy to calculate, y bar is easy to calculate. Again, x bar sum of the inputs divided by n simple average. Y bar sum of all the output observed divided by n simple average for the outputs. The summation of the squares of all the inputs minus n x bar squared. So this is everything's given. So we can find beta 1 found. So this is my slope, and the intercept, once I know my slope, going back, plug it in here, slope goes into this formula from my first equation, x bar given, y bar given, calculate, we'll find beta 0. So this way you will uniquely find a line identified on the plane with the slope and the intercept. And this will be the line of the best fit, which represents the least squares approach. I just derived the formula for you using calculus way, and if you do not like derivatives, I will use way number two, precalculus. Let's forget about the derivatives. I just need to analyze my value here, expression here. Yeah. What is that? That's beautiful, actually, summation of the parabolas. Parabolas. With respect to each one of those variables, beta 0 or beta 1. So let me write out those two parabolas separately. Let's say first parabola will be shown for the beta 0 variable. Second parabola for beta 1. So parabola number 1. Parabola number 1. Let me filter out all the powers of beta 0. The highest powers here, the degree, is beta 0 squared plus beta 0 first power. Let me collect the terms with beta 0. Beta 0 also 2 beta 1 xi. 2 beta 1 xi minus this term 2 minus 2 yi minus 2yi. Yeah? So that is my two terms with beta 0, second power, first power, and the rest is no beta 0 term, which is yi squared minus 2yi beta 1 xi plus beta 1 squared xi squared. I runs from 1 to m. Look at this. It's a beautiful parabola where beta 0 is my variable. The rest is constant. It's given. Yi given. Beta 1 will treat it as a constant in this case. I'm trying to minimize this parabola using beta 0 as my variable while keeping beta 1 fixed. So you need to minimize it, yeah? And my parabola number 2 will be the sum. I runs from 1 to m. And now I will look at the same thing as the parabola with respect to beta 1 variable. I will collect the powers of beta 1. The degrees here, the highest power, it's xi squared beta 1 squared. Now let me collect beta 1, beta 0, beta 1. From this term beta 1, we'll have 2 beta 0 xi, 2 beta 0 xi, 2 beta 0 xi. And from this term, minus 2 xi yi, minus 2 xi yi. So I collected beta 1 to the first power, and the rest is those terms yi squared plus yi squared minus 2 yi beta 0 plus beta 0 squared. Also mean. So here I have two parabolas, and again I need to show, it's easy to show, they are both have minima values. Why? The highest power of the variable is 1 here, positive, gets added positive, means branches go up, will be minimum with the parabola. For the beta 1 variable, I have the same thing. The coefficient of the highest power is xi squared, which is obvious. Obviously, it's a positive value. Observations of all the inputs squared. And again, the branch will go up. Those two parabolas have a point of minima. And how would you find that minimum point? You remember from precalculus, simple formula, x min minus b over 2a. Remember that. You all know it, you all remember that. So the minimum for the first parabola will be beta 0 min minus this expression of the first power of the variable, which is minus that, minus plus, so 2, and actually it's under the summation. Everything is under the summation. Don't forget what the summation. So it's summation 2yi minus 2 beta 1 xi divided by 2a, by the summation of 2. Yeah. Let me check again this beta 0 term. When I collect beta 0 minus 2y, and I collect beta 0 here, 2 beta 1 xi. Okay. Yeah. So I can reduce 2 everywhere. I can reduce 2's, and I will get the summation of yi's minus, that's everything under the summation here. 2 reduces, beta 1 out, minus beta 1, summation of xi's, and divided by n. When I reduce 2, it will be summation of 1 to itself n times. So it's divided by n. And actually, this is what I exactly have. The same formula. yi over n, it's y bar. It's y bar minus beta 1 x bar. That's the same formula I received while using my calculus approach. That's for beta 0. So now I need to find beta 1 using the same approach, just carefully. So it's easy to overlook something. A lot of terms here. So it's first and second. First equation, this will be my second equation. Careful. So beta 1 minimum. Yeah, beta 1 minimum. It's the same approach. It's minus this expression of the beta 1 to the first power, and it's under the summation, yeah? So the summation of xi, yi, I will reduce 2, will be 2 everywhere. So summation is xi, yi, minus the summation of that. 2 is out, beta 0 out, minus beta 0, the summation of xi's, minus beta 0, summation of xi's. So 2 is here, 2 is here, and divided by 2, that's why I'm reducing my 2, divided by 2a, which is the summation of xi's, the summation of xi's squared. Yeah? Almost there. The same way I can plug beta 0 in here. I can plug the value of my beta 0, and obviously will be the same result. So this beta 0 Okay, which came from here, but this is my beta 0, yeah? So once I plug in here, actually the rest is the same. Let me just do the algebra. So we'll beta 1 minimum, obviously, sum xi squared, and it's equal to summation xi yi minus beta 0 is this, yeah? Or from calculus, it's minus y bar minus beta 1 x bar, and multiply it by xi summation. We're almost there, almost the same, yeah, everything is the same. It's equal to the summation of xi yi minus y bar summation xi minus y bar summation of xi's minus plus beta 1 x bar summation xi, and that's equal to beta 1. And this is another term, beta 1. Yeah, let me collect this. It will be beta 1 summation of xi squared. So I will collect those terms. Let me write it here, which is beta 1 is out, and here I have summation of xi squared minus, yeah, moving this beta 1 here with a minus sign, minus x bar summation xi's, summation of xi's, and it's equal to the summation of xi yi minus y bar summation of xi. And we are done practically. Beta 1 from here is equal to, I need some space, hopefully I'll be able to fit in here. Beta 1 is equal to the fraction, the summation of xi yi minus y bar, and the summation of xi's is mx y bar over the summation of xi squared minus, and again, summation of xi's is mx bar by this x bar. So the mx bar squared. And here we are arrived at the formula for our slope, beta 1, the same as this beta 1 using calculus approach. And this is pre-calculus approach. This is the same results. And beta 0 is easy. Also, calculus approach, beta 0 is here. Once we know beta 1, plug it in, calculate, y bar, x bar, easy calculate given, beta 0. And the same formula for beta 0 is here, while I was using pre-calculus approach. As you can see, I just demonstrated two ways of defining a line of the best fit, the regression linear function. I hope that was clear, informative, useful, and interesting. Those two ways, and also I hope you enjoyed that. Thank you very much. Have a nice day. Talk to you soon.